Okay, square root of 7 plus 2 root x equals 2 plus root 3. Well, one approach we often use on radical equations, which is this, is to back solve, to plug in the answer choices. Unfortunately, we're going to get numbers here that aren't working out to nice integers. But we can still do it. That's not a problem. I mean, if you know square root of 3 is about 1.73, we know 2 plus 1.73 on the right side is 3.73. So what numbers would make the left side 3.73? Well, 7 plus 2 times 0, square root of 7, is not 3.73. 3.73 is the square root of something closer to 16 or 15, something in that ballpark. Okay, well, what about 2 root 2? Well, root 2, we might note, is 1.41, so that would be 2.8 plus 7, 9.8, still too low. How about root 6? Root 6 is going to be about 2.4 thereabouts, 2.3. So call that, 4.6, 11.6, still too low. Looks like the answer is going to be 12. 2 root 12, which is essentially 2 root 3. It's going to be 4 root 3, or 4 times 1.73, which will be just about 7 plus 7 would be the square root of 14, which is in that ballpark of what would give us 3.73 on the other side. That looks like it's going to work. Okay. Had to do a little estimation there to make that happen. How about solving this more formally? How would we go about that? Let's take a look. First thing I would do is square both sides. Okay. I'm going to get 7 plus 2 root x on the left side. On the right side, a square. I'm going to take advantage of the structure of a square. I square the first, 4, plus double the product of the 2, that's 4 root 3, plus square the second, which square root of 3 squared is just 3. Well, that's going to be nice. I'm going to get a 7 combining like terms there. 7 plus 2 root x equals 7 plus 4 root 3. And the 7s, which I said was nice, cancel out nicely. 2 root x equals 4 root 3. Okay, I could rewrite this, that root x equals 2 root 3, which I could put the 2 back into the radical as 4. So 4 times 3, this is root 12. X equals 12. 2x squared minus 3x divided by 2x minus 1. So I've got the following rational expression, and if I scan the answers, I'm not going to get a unique answer quickly from the remainder theorem. So I'm going to jump into this right into the long division. Let's set it up. So I need to multiply the 2x by x to get my 2x squared here. And then I need to multiply my x by minus 1, which is minus x. So 2x squared minus 2x squareds cancel. Minus 3x minus x. Don't forget, we're subtracting this row here, so that's a plus x, is minus 2x. So what would I have to multiply 2x by? Well, negative 1 in this case. So negative 1 gives me negative 2x plus 1. So again, I'm subtracting the second row. So it'd be 0 minus 1. My remainder would be minus 1. And that would be x minus 1 minus 1 over 2x minus 1. That would be your answer. That's option C. Let's real quick just check the remainder theorem to make sure I have the signs right, because there is a plus 1, minus 1 options there. So the remainder theorem says I would use here, C would essentially be 1/2, and I'll plug that into the function, which would then be 2 times 1/2 squared minus 3 times 1/2, and that equals 2/4 minus 3/2, which is essentially 2 minus 6 over 4, and that is negative 1. We have the right sign. Checks with my remainder over here. The answer is x minus 1 minus 1 over 2x minus 1.